Alright, welcome back to some more fun with math. In this video or lecture, I was going to look specifically at reading different types of graphs. This is kind of more of an overall review of all the different types of graphs that you may have, and examples on how to read them. So the first one that I wanted to start with is about reading tables. Now, with it, you need to be sure that you are answering your question very carefully. With a lot of these graphs, what you're going to notice is that you're given these big, huge, giant paragraphs before it, and the questions don't come down till after it. Most of the time, what's in these paragraphs is unnecessary information. And the question itself is what you really need to know. So this paragraph here is talking about warm weather and that a person can feel hot because of the reduced heat loss from skin with higher humidity and so on and so forth. Okay, and it's basically explaining what you're seeing in the table. The first question here says, find the apparent temperature for the given actual temperature and humidity conditions. So the little degree sign here that you can see means temperature. The percent means humidity. So when we were looking at this grouping pair here, we are looking at temp and then a comma and humidity. Okay, those are what those numbers stand for. Temp is first. So when we want to know the conditions when a temperature is 90 degrees with 70% humidity, what we have to do is we have to be able to go into your table and look. So notice this column right here is my actual temperatures, and so I want a temperature of 90%, so I am looking specifically at this row. Okay, so I've got this row of temperatures here. This is my 90%. And then I want a humidity of 70. So if you notice, my labels up here across the top are my humidities. So I am looking specifically down here at my 70%. And so there we go. Okay. And so in order to actually find my result, what I am specifically looking for is I am looking for the place in my data table where my two bars cross each other. In other words, they cross right here at this 111 spot. So because that's the spot where we cross, which is this spot right here, then that means the answer to the first question would be 111 degrees Fahrenheit. Okay. Now the second question says that at a relative humidity of 90%, what actual temperatures give an apparent temperature above 100? So when we're talking about above 100, we are talking about looking at the very specific column. So we want the 90% column. So here is 90%, so I'm going to draw this in red. So notice this is my 90% column. And when I'm looking at this column, I want to know which temperatures are giving me an apparent temperature above 100. So my apparent temperature are all these temperatures here in the middle. So I'm looking down my 90% column, and I am looking specifically at all of the temperatures that are greater than 100. So we're looking at this 108, 118, 127, 137, 146. So in order to figure out the actual temperature, we need to go straight across over to its temperature. So notice if I look at 108 and if I kind of go straight across, so I'm coming and I'm looking straight across my table over to, say, its parent spot, I've got 85. The same thing, 118 would come straight over to 90. This would come straight over to 95. Here we go to 100, and my last one comes over to 105. So that means for this one, when we're talking about the actual temperatures, we're talking about temperatures of 85 degrees, 90 degrees, 95 degrees, 100 degrees, and 105 degrees. And so you would list them out exactly like that. And that's how you go about reading a table. Okay? Let's look at something a little bit different. So here, this is called a pictograph. Pictographs are kind of fun. A pictograph is a graph that uses pictures to represent values, and they're usually set in table form, where your picture is going to give you a key definition. So here, the pictograph shows various energy drinks and the amount of caffeine in a 12-ounce serving. So notice I have a bunch of different energy drinks here, and I have a bunch of different cans. And notice a couple of these cans are not all the way. They're kind of cut. So here it shows you that one can is equal to 20 milligrams of caffeine per 12-ounce serving. So what does that mean? It means if I look right here at my Monster, notice I have 1, 2, 3, 4, 5, 6 cans. So if I want to know milligrams of serving, I would have 6 cans times 20 milligrams each would give me the total number of milligrams that I have. So here I would have 6 times 20, which is 120 milligrams total. So this would give me 120 milligrams of caffeine total in all of those cans. Okay, so that's just an example. Now again, here we have to be able to use our questions to answer. So here the first thing it says is which energy drink has the least amount of caffeine. So when we're looking at all of them, notice all of them have 1, all of them have 2, all of them have 3. See how they kind of line up? They all have 4, they all have 5. But Red Bull only has part of the 6th can, but the rest of them have 6. So here, this one only has 5 full and 1 part. Therefore, the energy drink that has the least amount of caffeine would have to be your Red Bull, because it only has a part of a 6th can. Now the second part of the question says, how much more caffeine is in a 12-ounce serving of No Fear versus a 12-ounce serving of Rockstar? So here, when we're looking at them, what we have to remember about this pictograph is that the pictograph is showing you the amount of caffeine in one 12-ounce serving. So here, we're telling you that one 12-ounce serving of Red Bull has this much caffeine. Okay? So if I want to know which has more, No Fear, which means I'm looking at this one, or Rockstar, looking at this one, I have to look at what is going on with them. So first things first, my Rockstar has 1, 2, 3, 4, 5, 6 cans. So here again I have 6 cans times 20 milligrams each is going to give me 120 milligrams of caffeine. My No Fear has 6.5, so this would be 6.5 at my 20 milligrams. So my 6.5 is going to give me 130. In order to figure out how much more caffeine is in No Fear, we simply have to do that 130 milligrams minus 120 milligrams equals 10 milligrams. So in other words, we would say that No Fear has 10 milligrams more than Rockstar. Now the biggest thing you need to remember about all of these graphs and analyzing the graphs is that you are drawing conclusions. So it's a lot more than just simply writing 10 milligrams. It's about actually drawing the conclusion behind what it is that you were talking about. So pictographs. Alright, another type of graph we have is a bar graph, or better known as the histogram. So when we're talking about these types of graphs, bar graphs or histograms, we use them to represent values. They can be shown vertically or horizontally. A horizontal bar graph tells you that the dependent variable is shown on the horizontal axis. Okay? You notice your bars are going to move left to right. It almost looks as if they're laying on their side. A vertical bar graph essentially tells you that one of the axes does not have a numerical scale. The bars are going to move up and down. Okay? A histogram indicates data in an actual class, which is a range or interval of numbers. And then we have a few definitions that we have to keep in mind. First, a class. Class means the range of numbers, okay, i.e. the range of the numbers in your bar graph. Then we have what's called a lower class. A lower class is going to be the smallest whole number that belongs to a specific bar or specific class. Upper class is the largest whole number. Now notice, whole number is the important part to remember there. And the reason for that is because we also have what are called boundaries. Boundaries are going to be the halfway mark between the upper and the lower classes. Now, frequency tells us the number of data items that you have in the class. And your class width is basically telling you the difference between your boundaries. In other words, how big that bar is. So what I want to show you here is an example of a bar graph as well as an example of a histogram. Alright, first let's look at the bar graph. So we have spending habits in a recession, and that the following bar graph shows the percent of men and women that will cut back in several different areas. The overall idea is that we are talking about spending habits. So here, the first question says, in which area did men spend the most? So notice, men and women are my key. Men are dark shades. Women are the light shades. And we're looking at where are the dark shades the highest. So you kind of have to look at the different dark shaded bars. And when we're talking about where men spent the most, you can see that very clearly eating out is the highest bar. So here you would be able to state that you are eating out. Now the second question says, in what area did men and women vary the most? So when we're talking about vary the most, we're talking about the difference. So if we look, notice online shopping, men would be, say, I would guess roughly 55, women would be roughly 55, whereas men might be closer to around 41 or 42. And so here we're looking at a fairly large difference, roughly 10 or above. And the rest of the bars, notice they're pretty close. Here for shopping retail, we have roughly 70 and roughly 60. So that would be maybe exactly 10, but here we're going a little bit more. Eating out, we've got maybe a little over 70 to about a little over maybe 66. Okay, that's even closer. And entertainment, again, we're doing a rough estimate, so maybe 71 to like 62. Okay, so they're all very close, but when we're talking about where they varied the most, I would have to say online shopping shows the biggest gap difference. Now, if this bar on the other hand, or this other side here, actually showed all the tick marks so that you weren't guessing, you would be able to tell specifically what these all were. But in terms of visualization, you would be very safe to guesstimate that it was the online shopping that has the biggest spread. So that's kind of what you do when you're looking at bar graphs and comparing one to another. Now the histogram here is going to be slightly different, because your histogram is going to ask you to kind of go through and analyze it completely. So here this histogram is summarizing scores of 50 students for a placement test. So the first thing we want to know is how many classes are represented. So remember, this is asking you essentially how many bars do you have. So we would count that this would be, say, 1, 2, 3, 4, 5, and 6. So we would say that we have 6 classes represented. Now the next one says, what are the class limits of the first class? So this is my first class here. So the limits that we want to know is we want to know the whole numbers that this is going between. So when we're looking at them, this first one in terms of class limits, essentially we would round up on the small side and down on the large side. So here you would say that we are roughly going between 201 to 250. Now the second one, or next question, wants to know what the boundaries are of the second class. So the second class is right here. And we would actually state the numbers that you see. So your boundaries are going to be these values here because they fall on the half. And so this we would say is that we go from 250 and a half to 300 and a half. Now the next one wants to know the class width. So the class width essentially is talking about the distance here that we have. So we would look at, you would run your subtraction. So we're looking at a width here of 50. Now this question, or the next one, wants you to identify the class that has the greatest frequency. And then what is that frequency? So the greatest frequency is essentially talking about the class that occurs the most. So here, when we're looking at all of these, the one that occurs the most would be 2. So this would be that we have class 2. And then the question wants to know what the frequency is. So here we're looking at the bar graph 2. Notice it comes up just about as high as 16. So here you would have a frequency of 16. We then want to know the percent of scores that fall between 200.5 and 250.5. So we are looking at this first class here. So the first thing we want to know is roughly how many fall in this category. So if we look at this between 0 and 4, notice my bar comes about halfway up. So we would say that we have a frequency of 2. So to find a percent says that we are going to take the frequency of 2 divided by your class width, which is the 50. And so here, this is going to give me 0.04. Again, to get a percentage, says we have to multiply by 100%. So this would be 4%. The last one wants to know the percent of scores that are above 400.5. So 400.5 falls right here. So we are looking just in this direction. So we need to know the number that sits at 5 and the number that sits at 6. So if we look, 5, we could kind of draw a cross, and it comes across about to 8. If we look over here at class 6 and we draw it across, we're looking at about 4. So here we are looking at 8 plus 4, and then over the 50 students. So here 8 plus 4 is going to give me the 12 over my 50 students. And where do I get 50 from? In the beginning, that we have a total of 50 students. And so here we would go ahead and do that division. So 12 over 50 is 0.24. So this is 0.24. Again, we need to multiply by 100%. So that gives us 24% of students fell in those classes. Okay. And so that is the difference between looking at just simply a bar graph and actually doing a histogram analysis. Alright, another type of graph we have is line graph. So again, a line graph is showing you a relationship. So your relationship is between whatever your y-axis is and your x-axis. So in this particular bar graph, notice my x-axis is talking about years and my y-axis is talking about how much it cost for a 30-second commercial. And remember, this is in millions of dollars. So when we look here at, say, 1.0, this would be $1 million. 0.8 would be like saying 800,000. Okay, so keep your units, be aware of your units. So here, our question wants to know the cost of a 30-second commercial in the year 2010. So when we're looking at the year 2010, we are specifically looking at, here's 2010, and so we are looking at this line right here. And what we're looking for is we're looking for where on this line did we actually cross. Once we figure that out, then we would go from that point and we would go like directly over to the other side, and we would kind of look at where did we fall. So here my point is falling halfway between 2.8 and 3.0. So in terms of the cost, we are looking at 2.9 million. And you must put this label here specifically because of what it says, that this is millions of dollars. Now this last question says, in between which 2 years was the greatest increase in cost for a 30-second Super Bowl commercial? The biggest advice I can give you here is not to guess. So we're talking about an increase. So immediately that's going to knock this first part out. So what you essentially would need to do is you would need to start kind of rough guessing on what looks like the sharpest increase. So when you're looking at it, notice most of them are fairly little. All of a sudden we get to this piece right here, and we get a fairly sharp increase here, kind of sharper than anybody else. So it would be safe to say that we are looking at between these 2 years as being the largest increase. And so your answer here would be that we're looking between 2011 to 2012. Okay, and so those are just a couple examples on being able to read line graphs and pick out the information that is necessary. Alright, the very last type of graph that I wanted to look at here is a circle graph. Circle graphs usually show percents. They're also a relation or a comparison graph. You need to pay very close attention when dealing with circle graphs that you are answering the question the way they want and not the way you assume. So this one says that in recent years a rising number of Americans have more money in savings than they have in credit debt. The following circle graph shows savings and spending of different percentages. So here we have this broken out. So this big giant pink area is 55%, and it's relating to more emergency savings than debt. So this would be 55% of Americans. The purple area here says that 24% of Americans have more debt than savings. Over here we have 16% have no debt and no savings, and this yellow area here is 5%, and that represents no idea about savings or debt status. Okay. The first question says, what percentage of Americans have no debt and no savings? It is just as simple as picking it out, matching what I'm asking for to the title of the piece of the pie. And this would be 16% have no debt and no savings. The next question says, if this graph was created using 25,750 Americans, how many Americans have 24% more debt than savings? So here we're talking about more debt than savings, so we have to take that 25,750 and we need to multiply that by the 24%. So remember, a percent is the same as a decimal, so this is the same as saying 25,750 times 0.24. And when we multiply that out, we end up with 6,180 Americans. Okay. So there you have it. A little snapshot on all the different types of graphs that we have and how to attack problems asking you to analyze with them. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this lecture. Keep smiling, and I'll see you next time.